Section 10-2, Similar Figures. A two-dimensional figure is similar to another two-dimensional figure if you can map one figure to the other by a sequence of rotations, reflections, translations, and dilations. The symbol here that I'm drawing, this symbol here, means is similar to. This symbol means is similar to. So let's look at this figure. Here we have a rectangle, A, B, C, D. Suppose you start with this rectangle, A, B, C, D, and you translate it 6 units to the left and 1 up. So, taking this rectangle here, if I move it 6 to the left, 1, 2, 3, 4, 5, 6, and 1 up, I have the rectangle that is now pink. So I translated this rectangle to the left 6 and up 1, okay? Next, if I rotate this rectangle, rotate it 90 degrees. So from this point here, I'm going to rotate it 90 degrees, and this is what it would look like. Okay? So I took the rectangle that I had when I moved it to the left 6 and up 1, and then I've rotated it 90 degrees, and this is what it looks like. When I rotated that rectangle 90 degrees, this is what it looks like. Now, next we're going to reflect it across the y-axis. So next, let's reflect this rectangle, reflect across the y-axis. So if we reflect this rectangle, look, it's 2 units to the left of your line of reflection. So if you reflect it over, if I take this rectangle and I reflect it over the y-axis, if I reflect it over the y-axis, it's now 2 to the right. See, it was 2 to the left when I flipped it over, now it's 2 to the right, okay? So I have now reflected my rectangle across the y-axis, okay? Now, so here I am, I've reflected it over the y-axis. Next, finally, it says, dilate it by a scale factor of 1/2. So we're going to dilate it by a scale factor of 1/2. So if you dilate a rectangle by a scale factor of 1/2, remember, if your scale factor is less than 1, then the rectangle will get smaller. It's actually 1/2 means it's going half this size, okay? If the scale factor is greater than 1, you're enlarging it. So we're reducing. This is a reduction. We're going to reduce this rectangle by 1/2. So look at our figure here. It has been reduced by 1/2. When I look at this figure, I see that it has a width of, or crossways, it has 1, 2, and then going down 1, 2, 3, 4, okay? So what happens is, when you multiply each of these ordered pairs times 1/2, it's just going to move it in. Instead of being 2 across, it would be 1 across. Instead of being 4 down, it's going to be 2 down. But to actually find the ordered pairs of the newly reduced rectangle, we would take each one of these ordered pairs that represents this rectangle here, multiply each number in the ordered pair times 1/2, like we did in our last video, and find the newly ordered pairs of this reduced, or the reduction rectangle. So the final image is still similar to a rectangle A, B, C, D. So here we have our original rectangle. It was translated to the left 6 and up 1. Then we rotated it 90 degrees. Then we reflected it over the y-axis. And then we reduced the size by half. So the final image is still similar to the rectangle ABCD. We call these rectangles similar rectangles.